Welcome back to our channel. Today, we embark on an extraordinary journey to unveil the intriguing tale of India's mission to the moon, known as Chandrayaan. Join us as we step into the world of space exploration and unveil the secrets held within our celestial neighbor. The Chandrayaan is the Sanskrit word which means moon craft or moon vehicle, also known as the Indian Lunar Exploration Program, is an ongoing series of outer space missions by the Indian Space Research Organization for the exploration of the moon. The program incorporates a lunar orbiter, an impactor, a soft lander and a rover spacecraft. There have been 3 missions so far with a total of 2 orbiters, landers and rovers each. While the 2 orbiters were successful, the first lander and rover, which were part of the Chandrayaan-2 mission, crashed on the surface. The second lander and rover mission Chandrayaan-3 successfully landed on the moon on August 23, 2023, making India the first nation to successfully land a spacecraft in the lunar South Pole region, and the 4th country to land on the moon after the Soviet Union, the United States and China.
Let's begin with the first mission, which was sent to Moon by Indian Space Research Organization. The mission was launched from Satish Dhawan Space Center, Sriharikota, Andhra Pradesh on October 22, 2008. The visuals show how Chandrayaan-1 was launched. It was nation's first mission to Moon. Scientists were much eagerly waiting for this historic movement to occur. The mission was a major boost to India's space program, as India researched and developed indigenous technology to explore the moon. The vehicle was inserted into lunar orbit on November 8, 2008. The then Prime Minister of India Atal Bihari Vajpayee announced the Chandrayaan-1 project. The idea of an Indian scientific mission to the moon was first raised in 1999 during a meeting of the Indian Academy of Sciences. The Astronautical Society of India carried forward the idea in 2000. Soon after, the Indian Space Research Organization set up the National Lunar Mission Task Force, which concluded that ISRO has the technical expertise to carry out an Indian mission to the moon. Former president, including few scientists, can be seen commenting on the launch of Chandrayaan-1.
Indian Space Research Organization, where Chandrayaan-1 was launched. The major objectives of the launch of Chandrayaan-1 was to conduct high-resolution remote sensing of the moon's surface. Study the mineral composition and distribution of elements on the lunar surface. Search for water ice on the moon, particularly in the polar regions. Investigate the moon's exosphere and its interactions with the solar wind. Join us on an incredible journey to the moon as we explore the successful mission of Chandrayaan. Discover fascinating facts, stunning visuals, and the scientific achievements behind India's lunar exploration program. As we gaze at the moon from our planet, its tranquil surface hides the tales of billions of years of celestial history. Chandrayaan's mission was to analyze lunar soil, map lunar surface, and study the presence of water and minerals. These crucial discoveries would aid future lunar missions and our understanding of the moon's formation. Accomplishing a lunar mission requires significant challenges. Let's explore the remarkable achievements of Chandrayaan and the hurdles faced along the way. In 2008, Chandrayaan-1, the first lunar mission of India, successfully launched. It was equipped with a wide array of scientific instruments, including the Moon Impact Probe and a moon mineralogy mapper. Chandrayaan-1 marked India's entry into the exclusive club of countries that had successfully reached the moon.
Technical specifications of Chandrayaan-1 are: weight 1,380 kilograms, 3,042 pounds, at launch, 675 kilograms, 1,488 pounds, at lunar orbit, and 523 kilograms, 1,153 pounds, after releasing the impactor. Dimensions: cuboid in shape of approximately 1.5 meters, 4.9 feet. Communications: X-band, 0.7 meters, 2.3 feet, diameter dual gimbaled parabolic antenna for payload data transmission. The telemetry, tracking and command, TTC, communication operates in S-band frequency. Power: the spacecraft was mainly powered by its solar array, which included one solar panel covering a total area of 2.15 by 1.8 meters, 7.1 by 5.9 feet, generating 750 W of peak power, which was stored in a 36 ampere-hour lithium-ion battery for use during eclipses. Propulsion. The spacecraft used a bipropellant integrated propulsion system to reach lunar orbit as well as orbit and altitude maintenance while orbiting the Moon. The power plant consisted of one 440N engine and 8 22N thrusters. Fuel and oxidizer were stored in 2 tanks of 390 liters al. each. Navigation and control. The craft was 3-axis stabilized with 2 star sensors, gyros, and 4 reaction wheels. The craft carried dual redundant bus management units for attitude control, sensor processing, antenna orientation, etc.
However, reaching the Moon was just the beginning of the journey. Overcoming technical difficulties and coordinating complex maneuvers, the scientists and engineers at International Space Research Organization paved the way for Chandrayaan-2, a more ambitious mission. After almost a year, the orbiter started suffering from several technical issues including failure of the star tracker and poor thermal shielding. Chandrayaan-1 stopped communicating at about 2000 hours Universal Time Coordinated, 1:30 Indian Standard Time, on August 28, 2009, shortly after which the ISRO officially declared that the mission was over. Chandrayaan-1 operated for 312 days as opposed to the intended 2 years, however the mission achieved most of its scientific objectives including detecting presence of lunar water. Chandrayaan-2 is the second lunar exploration mission developed by the Indian Space Research Organization, after Chandrayaan-1. It consists of a lunar orbiter, and also included the Vikram lander, and the Pragyan lunar rover, all of which were developed in India. The main scientific objective is to map and study the variations in lunar surface composition, as well as the location and abundance of lunar water. The spacecraft was launched on its mission to the Moon from the second launch pad at the Satish Dhawan Space Center in Andhra Pradesh on July 22, 2019 at 9:13 and 12 seconds Universal Time Coordinated, 14 hours 43 minutes and 12 seconds IST, by a GSLV Mark III M1. The craft reached the Moon's orbit on August 20, 2019 and began orbital positioning maneuvers for the landing of the Vikram lander. The lander and the rover were scheduled to land on the near side of the Moon, in the South Polar region at a latitude of about 70 degrees south on September 6, 2019 and conduct scientific experiments for 1 lunar day, which approximates to 2 Earth weeks. However, the lander crashed when it deviated from its intended trajectory while attempting to land on September 6, 2019. According to a failure analysis report submitted to Indian Space Research Organization, the crash was caused by a software glitch.
Chandrayaan-3 is India's next Moon mission. Chandrayaan-3 is the sequel of the Chandrayaan mission. Its predecessor were Chandrayaan-1 and Chandrayaan-2. The spacecraft launched to the Moon on July 14, 2023, at 5:05 a.m. Eastern Daylight Time, 9:05 GMT or 2:35 p.m. local time July 14, from the Satish Dhawan Space Center in Sriharikota, Andhra Pradesh, India atop the medium-lift launch vehicle Mark III, LVM-3, rocket. The Chandrayaan-3 is built on a budget of just under 615 rupees crore or $75 million. The Chandrayaan-3 weighs about 3,900 kgs. It consists of a lander named Vikram and a rover named Pragyan, similar to those of the Chandrayaan-2 mission. The propulsion module carried the lander and rover configuration to lunar orbit in preparation for a powered descent by the lander. The spacecraft entered lunar orbit on August 5, and the lander touched down in the lunar South Pole region on August 23, 2023 at 12:32 Universal Time Coordinated or 6:03 p.m., making India the 4th country to successfully land on the Moon. The propulsion module carries the lander and rover configuration to a 100-kilometer lunar orbit. It is a box-like structure with a large solar panel mounted on one side and a cylindrical mounting structure for the lander on top. Lander or Vikram lander is responsible for the soft landing on the Moon. It is also box-shaped, with 4 landing legs and 4 landing thrusters capable of producing 800 newtons of thrust each. It carries the rover and various scientific instruments to perform on-site analysis. The lander has 4 variable thrust engines with slew rate changing capabilities. Prime Minister Mr. Narendra Modi was witnessed this launch from Johannesburg, South Africa. Scientists' happiness were very obvious. This was the outcome of ISRO's scientists. They were doing hard work throughout this mission. Later, when PM Modi visited ISRO, he said it is not the achievement of India only, but he gave credit to all the world for this achievement, including the science of Indian Space Research Organization. The mission objectives of Chandrayaan 3 are to demonstrate safe and soft landing on lunar surface, to demonstrate rover roving on the moon, and to conduct in situ scientific experiments. To achieve the mission objectives, several advanced technologies are present in landers such as altimeters, laser and RF-based altimeters, velocimeters, laser Doppler velocimeter and lander horizontal velocity camera, inertial measurement, laser gyro-based inertial referencing and accelerometer package, propulsion system, 800N throttleable liquid engines, 58N attitude thrusters and throttleable engine control electronics, navigation, guidance and control, NGC-powered descent trajectory design and associate software elements, hazard detection and avoidance, lander hazard detection and avoidance camera and processing algorithm, landing leg mechanism. Rover or Pragyan rover is a 6-wheeled vehicle with a mass of 26 kilograms, 57 pounds. It is 917 millimeters, 3.009 feet, x 750 millimeters, 2.46 feet, x 397 millimeters, 1.302 feet, in size. Here is how Pragyan rover descending down from lander to the lunar surface. The rover is expected to take multiple measurements to support research into the composition of the lunar surface, the presence of water ice in the lunar soil, the history of lunar impacts, and the evolution of the moon's atmosphere.
One of the most significant discoveries of Chandrayaan was the presence of water molecules on the moon. This finding helped validate the long-held hypothesis and opened doors for future lunar missions capable of utilizing these resources. Chandrayaan's mapping of the lunar surface provided invaluable insights into the moon's landscape, craters, and potential landing sites for future missions. The mission helped refine our understanding of the moon's evolution and the geology of other celestial bodies. Chandrayaan's successes have sparked enthusiasm and laid the foundation for future endeavors in India's space program. With plans for lunar sample return missions and the vision of manned missions to the moon, India continues to push the boundaries of space exploration. With Chandrayaan, India embarked on an awe-inspiring journey, unraveling the moon's mysteries and expanding human knowledge. As we conclude this video, we encourage you to stay curious, keep seeking answers, and join us on future expeditions to discover the wonders of our universe. Thank you for joining us on this captivating quest to the moon with Chandrayaan. Thank you for watching my YouTube video. Please like, share and subscribe my YouTube channel.